Your Telegram proxy worked perfectly last week, and today it just hangs. Nothing changed on your end. You did not touch a setting, the server is still running, the IP still answers a ping, and yet Telegram sits there connecting and never joins. It is easy to assume something broke. Usually nothing broke. What happened is that a network somewhere in the middle learned to recognize your proxy for what it is and quietly started dropping it. That is a completely different problem from a misconfiguration, and it needs a completely different fix. Let me walk through how a network spots a proxy, why plain mtproto is easy to catch, and how the trick called fake TLS hides it in plain sight. I run managed Telegram hosting on dedicated hardware here in Singapore, and keeping accounts reachable from networks that actively fight proxies is part of the daily job. When your whole promise is that an account stays online and usable, a proxy that works on Tuesday and dies on Wednesday is not acceptable. So I have spent real time watching which setups survive a hostile network and which get picked off in a day. This is not theory pulled from a forum thread. It is what actually holds up when something on the path is trying to find your proxy and shut it down. Here is the plan. How a network blocks traffic it does not like and why it does not even need to read your messages to do it. Why a plain proxy has a recognizable shape. What active probing is and how a firewall tests your server to be certain. Then the fix, obfuscation, and specifically what fake TLS does differently. How the secret and the domain buried in your proxy link actually work. Why both ends have to agree. And finally, the honest limits. Because obfuscation hides the shape of your traffic, but it cannot rescue a burned IP. By the end, you will understand why proxies get blocked and what actually keeps one alive. Start with how blocking happens at all, because the intuition is usually wrong. People imagine a sensor reading their messages and deciding to cut them off. That is not how it works at scale, and it does not need to. Telegram traffic is encrypted, so the network in the middle cannot read a single word of it. What it can see is the shape of the traffic, the size and timing of packets, the pattern of the very first bytes when a connection opens, which server you are talking to, and how the whole exchange looks next to ordinary browsing. A firewall that inspects traffic this way is studying the fingerprint, not the content, and a proxy has a fingerprint whether the payload is encrypted or not. Now why a plain proxy is easy to spot? When a basic proxy connection opens, the first bytes on the wire look like random noise, because that is essentially what obfuscated proxy traffic is. The trouble is that almost nothing else on a normal network opens a connection with a burst of pure randomness. Real web browsing starts with a recognizable structured handshake. So paradoxically, trying to look like nothing at all makes you look like exactly one thing. A proxy. A firewall does not have to know what you are sending. It just has to notice that this connection does not resemble any normal thing, and that alone is enough to flag it and drop it. There is a second, sharper technique called active probing, and it catches setups that a passive look would miss. When the firewall sees a connection it is unsure about, it does not simply guess. It connects to your server itself from its own machines and pokes it to see how it responds. If your server answers the way a proxy answers, the firewall now knows for certain, and it can block that IP for everyone behind it. This is why some proxies work for a few hours and then die. They were not blocked on site, they were tested, confirmed, and then switched off. A proxy that gives itself away when probed has a very short life on a serious network. So the answer is obfuscation, which simply means making your proxy traffic look like something the network is happy to allow. There is a ladder here. A plain SOCKS 5 proxy has almost no disguise and is the easiest thing in the world to block. mtproto added its own obfuscation, the random-looking stream, which is better but, as we just saw, still carries a tell. The strongest common option, and the one worth understanding, is fake TLS, and it takes a completely different approach. Instead of trying to look like nothing, it tries to look like the most ordinary thing on the entire internet. Here is what fake TLS actually does. Ordinary secure web browsing runs over TLS, the same protocol behind every HTTPS website you visit. Every one of those connections begins with a TLS handshake that announces in the clear which website you are reaching. Fake TLS wraps your proxy traffic so that it opens with exactly that kind of handshake, pretending to be a connection to a normal, real website. To the firewall watching the wire, your proxy connection becomes indistinguishable from someone quietly loading a web page. It is not hiding in the noise anymore. It is hiding in the crowd, inside the single most common kind of traffic there is. This is where the proxy link you paste in actually matters, because the disguise is baked into it. A modern mtproto proxy link carries a secret, a string of characters, and for fake TLS, that secret starts with a specific marker and then encodes a domain name inside it. That domain is the website your connection will pretend to be visiting. When you import the link, your Telegram client reads the secret, sees the fake TLS marker, and knows to dress every connection up as a visit to that domain. So the link is not just an address and a password. It carries the whole disguise, which is why a fake TLS link looks longer and more complicated than an old plain one. The domain buried in that secret is not decoration, and choosing it well is part of why one proxy survives while another does not. The connection genuinely pretends to be reaching that site, so it should be a real, popular, unremarkable website that the network would never dream of blocking, something huge and boring that everybody visits all day long. Pick a domain that is itself blocked or suspicious in the region you care about, and you have disguised your proxy as exactly the wrong thing. A good fake TLS setup borrows the reputation of somewhere the censor cannot afford to touch. Now the part that trips people up. Obfuscation is not a switch on one side. The server has to be running in fake TLS mode, and the client link has to carry the matching secret, and the two have to agree exactly. If the server speaks plain mtproto but you hand out a fake TLS link, or the other way around, the connection simply fails, and it fails in a way that looks like a dead proxy rather than a mismatch. This is the source of a lot of confusion. The proxy is not broken and the IP is not blocked. The two ends are just describing themselves differently, and neither will bend to meet the other. There is a small cost, as there always is. Wrapping everything in a TLS disguise adds a little overhead and a touch of latency, because there is an extra layer of dressing up on every connection. In practice, it is barely noticeable, and it is a trivial price for a proxy that actually stays reachable instead of one that gets picked off the moment a firewall tightens. Faster but exposed is not a good trade when the exposed version stops working entirely. On a network that fights proxies, the disguised connection is the only one still standing at the end of the day. But I want to be honest about the limits, because obfuscation is not magic. It is one move in a long-running back and forth. Fake TLS is very good today, but the people building firewalls study it too, and they hunt for subtle differences between a real TLS handshake and a proxy pretending to be one. A tiny imperfection in the disguise, an unusual detail in the handshake, a domain that does not quite fit the pattern, and the determined network can start telling the difference again. Nothing on this side of the fence is permanent. What works is staying current, not finding one clever trick and assuming it lasts forever. And here is the thing that matters more than any of it, the point people miss while they obsess over handshakes. Obfuscation hides the shape of your traffic. It does absolutely nothing for the reputation of the IP underneath. If the address your proxy runs on is already sitting on a block list, or it is a cheap data center IP that a network has decided to distrust wholesale, then it does not matter how flawless your fake TLS disguise is. The connection is refused before the disguise ever gets a chance to work. You can dress up the traffic perfectly and still be turned away at the door because of the address it is arriving from. So a proxy that genuinely survives is two things together, not one. A good disguise so the shape of the traffic passes, and a clean, trusted IP underneath so the address itself is welcome. Get only one of those and you are exposed on the other side. And even with both, discovery still happens eventually. An IP that gets found and blocked has to be replaced with a fresh one, and the whole setup pointed at the new endpoint, quietly, before the people relying on it even noticed the old one died. That rotation, spotting a burned endpoint and swapping to a clean one, is the unglamorous ongoing work that decides whether a proxy is reliable or a coin flip. Let me be clear about scope. because it matters. Everything here is about staying reachable, keeping a legitimate account online and usable from a network that blocks Telegram or throttles proxies, whether that is a restrictive country, a lockdown office, or a public connection that filters things. It is not about slipping past a ban you actually earned, and no amount of fake TLS will lift a ban that an account brought on itself. This is about the ordinary right to a stable private connection, not about hiding in order to cause harm. And here is the honest catch, the same one that runs under all of this. Running an obfuscated endpoint, pairing the server and the link correctly, choosing a sensible domain for the disguise, keeping the IP underneath clean and trusted, and rotating to a fresh endpoint the moment one gets discovered, is steady, fiddly, continuous work. It is not a thing you set up once and forget. And that quiet, ongoing effort, the part that actually keeps you connected on a network that is trying to cut you off, is exactly what managed hosting is built to carry. Telegram Vault is managed Telegram hosting on dedicated Singapore hardware, real handsets on real carrier SIMs from Singtel, M1, StarHub, and Vivify, so your accounts live on clean, stable mobile IPs that networks are inclined to trust in the first place, with the obfuscation and the endpoints handled and kept current, instead of a lone data center proxy that gets fingerprinted and blocked the week of firewall titans. If that is what you need, start at telegramvault.org. Onboarding begins with a real conversation about your setup, not a checkout page, and the code TGYT gets you a discount when you start. If this cleared up why a proxy that worked yesterday can simply stop today, and what it really takes to keep one alive, then subscribe, because there is a lot more on running Telegram accounts and infrastructure cleanly coming on this channel. Thanks for watching, and I will see you in the next one.